So now we'll understand the Cisco Access Control List or the ACL. So what is an access control list? ACL is used to actually control your network traffic from, say, coming from outside to your network, or it is originating in your network and it is going out. So any incoming or outgoing traffic you can filter, you can allow or deny using the Cisco Access Control List, and it acts as a firewall technology. It is inbuilt within the router IOS, so you do not need to purchase any additional firewall that is say hardware based because it's costly. So we'll understand this ACL. We'll explore the Cisco's access control list and their functionality. So ACL plays a critical role in network security by managing the traffic flow. So in network security, when the data is coming into your network or it is going outside the network, say you are accessing any server, say you are accessing any web server or a file server, so your traffic is outgoing. Or you are running a server, a web server in your network, and somebody is going to access that server. So in both cases, you can regulate the traffic flow using the ACL and the specified permissions for users and system, safeguarding them from unauthorized access or from any attacks. So if an attacker wants to attack your personalized servers, so you can protect them using the ACL. So it is just like the firewalls, but it is not the hardware based, or it cannot block any specific sites, but it can block the specific ports. It can allow or block any specific port numbers. Now, what are the Cisco ACLs in depth? Cisco ACLs are essential security features implemented in Cisco devices, and it is CLI based. It is not having a GUI interface, so you have to write the commands for setting up the ACL. They allow network administrators to define filtering rules that control the flow of traffic. Enhances network security by permitting or denying access. So that I've already told you that if some traffic is coming, I have to first make the deny rule, because if you allow the entire network, then if you specify a deny statement, then definitely it will not work because it is executed step by step. So if it sees on the first step that one PC or one IP is denied or one network is denied, and then it will discover that whatever the networks that are allowed. So first you have to block and then you have to allow the network, but if you do it otherwise, then it will never work. So the flow of traffic you have to understand. Then you have to permit or deny based on that. And the criteria can be IP address, protocols, port numbers, different. So you can block and allow these things. Now, what are the types of Cisco ACLs we have? We have standard ACL, we have extended ACL, and we have named ACL. These three types. So what is the standard ACL? Standard ACL are used to permit or deny traffic based solely on the source IP address. It only takes into account the IP address. It doesn't take into account any port number, protocol number, anything. And only the source IP means where the traffic is originating from. But it is not taking into account the destination where the traffic is destined to. And it is simpler and typically quicker to process and making them suitable for basic filtering. So they are fast. The one advantage of standard ACL is they are fast because they do not have to figure out the destination. They only see the source, not the destination. So that is why the processing is faster than the standard ACL and it takes less time. What about the extended ACL then? Extended ACLs provide more granular control over your traffic because it filters based on both source and destination IP. Say, for example, from 10.0 network, that is the source, I can deny the traffic to 20.0, but the 30.0 or 40.0 network means the destinations are permitted. That can be done using the extended ACL. As well as specified protocols and port numbers also can be filtered, means allow or deny. And it allows for more detailed security policy and practices. So if you compare between the standard ACL and extended ACL, so standard ACLs are designed to filter traffic solely on the source IP address, making them straightforward and efficient for managing access control. And so it is not having any such granular control or such detailed control, but it is easier to maintain. And as I've told you, it is faster. Whereas extended ACLs have the granular control over network traffic, and it has more comprehensive filtering mechanism, and it allows administrators to specify not only source and destination IP but also protocols and port number. Means you can also deny, say, the routing protocols, the EIGRP, OSPF, BGP, those routing protocols also. So the complexity enables a higher degree of control over network traffic, but it is slower because it needs a lot of processing. Now, standard ACL has a range between the 1 to 99, and extended ACL is range between 100 to 199. Now, how the ACLs work, we should understand. First of all, it works as the packet filtering. ACLs are designed to inspect each packet that passes through a network interface. So if you have configured the ACL, it will not work unless you implement it on the interface. So it will filter the traffic, it will monitor the traffic as the traffic passes through it. They check the packet's header information against the defined rules to make a decision whether to allow or deny the packet. Then the rule evaluation comes. When an ACL processes a packet, it evaluates the rules from top to bottom. One by one, it evaluates. And when it matches the rule, then the execution stops there. The asserted action, permit or deny, is applied, and no further rules are evaluated then. So when the rule is matched, that is the ultimate decision of the ACL. And always we have to remember there is implicit deny in the any form of ACL, standard or extended. By default, if a packet does not match any of the configured rule, it is automatically denied access because that is implicit deny or automatic deny. That is why if we deny a certain network, after that we have to explicitly specify the allow statement because otherwise every access will be denied. This implicit deny feature enhances security by ensuring that only explicitly allowed traffic is permitted. Explicitly means whatever we have permitted, that is permitted, otherwise everything is denied. So that is the theoretical discussion about the ACL, and now we'll configure the standard ACL first, and then I'll show you how to configure extended. So let me go to the Cisco packet tracer now. And as you have seen, there are two routers, router 0 and router 1 connected. We have to first configure routing, either the static one or the dynamic routing protocol there. And then we have to configure the standard ACL first. And then I will configure the extended ACL. So let me give the IP addresses on the router 0. The interface fast Ethernet. So IP address is 10.0.0.1. Interface is 2 by 0. Rocket 64,000. Shut. Address is 191.168.0.1. And I'm giving the default mask for now. And let's say I'm configuring OSPF. OSPF is ID 1 and the network it should be connected to area 0. So router 0's configuration is done, and now move to the router 1. The Ethernet port 20.0.0.1. And on serial interface, one 192.168.0.2. And configuring the OSPF here. 192.168.0.0. So the OSPF route has come, and now I will give the IP address to the PCs. It should be 10.0.0.2. And this would be 20.0.0. Now, if I configure standard ACL, then I will have to specify a source. Let's assume the source is 10.0. So I have to configure standard ACL on the destination because the standard ACL filters from the source. So you cannot configure on the source. So I'm denying this 10.0 network. So on the destination router, access list, what is the range? 1 to 99, as you can see, that is the range for the standard ACL, and 100 to 199 for the extended ACL. So access list 1, D9, 10.0.0.0, and the wildcard mask. Now, if I only give this statement, then everything will be denied because of the implicit denial. So I have to specify access list permit space any. So it means that any other network will be permitted, but only the 10.0 will be denied. And now we have to specify on which interface I have to implement it on the Ethernet port. And IP access group is number one, and out. Out is the direction. If you say after a serial number, if you give question mark, it will be in or out. In case of standard ACL, it is configured on the destination, so it will be outbound. And in case of extended ACL, as it is configured on the source, it will be inbound. And now just check by pinging from this PC 10 to 20. Go to command prompt and ping 20.0. It will show as destination host unreachable because of the ACL. So ACL is preventing the traffic from reaching the 20 network. And if you go to this router 0, and if I show access list, it will not show anything. But if you give show IP access list, you will not find anything because it's the source. But if you go to the destination and if you give show access list, you will find that there is an IP access list 1, and these are the line numbers 10, 20. It is denying the packet and it has denied 4 packets. So it is 4 matching packets, means the 4 ICMP requests it has denied. And if I give here show IP access list, the same will come. So this is the power of the standard ACL, and this is why we can deny the packets. So that is about the standard ACL that I've shown you, and I will configure the extended ACL in the next video.